is Caroline, and I'm the vision programmer for 18438 Wolfpack Machina. This video is going to be a brief explanation on how to set up vision code entirely from scratch, including what camera to buy, as well as how to tune vision. There are many different uses for vision in FTC. For example, many users a vision task in auto, so you look at an April tag or an object, and that tells you where your robot needs to park. You can also use vision to detect scoring elements. So this year we have two different colored artifacts. You have green and purple, and it can be very useful in auto once again to be able to detect those and drive up to them to intake. You can also use vision to relocalize with April tags, which is very helpful since odometry pods tend to drift over time. The camera automatically sees and stores colors in RGB. This is something called a color space, and there's a bunch of different ones. The RGB color space looks like a cube with its axes being red, green, and blue. Every color is a mix of these. RGB are also the additive primaries, meaning that if you max out red, green, and blue values, you get white. While this color space works great for our computers, which are set up to have LEDs in red, green, and blue, it's pretty complicated to tune like this since you typically don't look at a yellow cube and think, well, this is the blue value and this is the red and this is the green. Instead, you think about how light or dark it is or what saturation it has, and you know it's yellow because of its hue. This color space is HSV, hue, saturation, and value. The HSV color space is a circular prism with hue, saturation, and value as its axes. This is a lot easier to use, so we'll be using this color space instead for vision tuning. I'll explain how to do that later when we go into the actual code. There are a bunch of differences within types of camera. First, let's look at rolling shutter versus global shutter. There's quite a few different types of shutter, but since those are the two most common in FTC, that's what I'll be going over. Rolling shutter cameras get each pixel in a frame by starting at the upper left corner and scrolling atop the top of the pixels, and then going down a row and doing the same until they get every row. This happens very fast and isn't really an issue most of the time, but when the robot is moving quickly, you get a lot of motion blur and errant detections. This is when there's random pixels that just show up and the camera thinks that's the right color. This also sometimes warps the shape of whatever you're seeing, and although the biggest cause of motion blur is exposure length, this rolling shutter does have some effect in that. Global shutter cameras capture all the pixels in the frame at once. This is a whole lot better for things like April tags, but it's also really helpful if you're trying to use the camera to auto-aim for something. Do keep in mind that global shutter cameras will have some motion blur because of exposure length, just not as much. Black and white global shutter cameras tend to be more expensive than rolling shutter cameras, like Logitech webcams, and color global shutter cameras are even more expensive. You may have heard of Limelight 3A cameras, which are a type of rolling shutter camera. However, they also have an internal processor, and you can write code for a Limelight camera. Since they're so fast, the fact that they're rolling shutter really doesn't tend to matter, but they're also incredibly expensive and don't tend to be in stock very often. Another important property of cameras is FOV. This is a more well-known idea, so I won't be going into as much depth with this, but Limelight cameras really don't have a great FOV, so if you need your camera to see a large area, say an entire tile, a Limelight camera might not work great for you. Now let's look at some of the code that makes all this happen. On screen is some code for how to set up your camera in your teleop. So starting off, we just have our normal teleop name. You can ignore this for now, I will explain this later. But we first start with our webcam name. This doesn't actually matter very much what this variable is called. This is just communicated to your driver station through this. So this is what will actually be set up as in config. And this is the default, I believe, when you just scan your config. We next up have our example processor. This will likely be an error if you just type it in as is because you don't actually have a processor yet. I will explain that in the next step of this tutorial. It is a separate thing, but the processor is where your camera is actually going to be doing all the processing of the frame it receives. But for now, we can ignore this. And this is also not required, but if you want to detect April tags through the same camera as you're detecting just color blobs through, I will explain how to do that as well, and you're going to need an April tag processor. This is a pre-made class that you can just access, thankfully, so you don't have to do too much setup. And Vision Portal is another pre-made class you're also going to need, and this should be good just as is. Your size is your camera resolution, or your camera resolution is a size object. With these variables can change based on what your resolution to be, but this resolution works pretty well for most types of cameras, so I just have it as a default for now. Within your init method, first off, you're going to set up your vision processor like this. If you want to set up an April tag processor, it's a similar process. However, you're going to need to include this builder.build thing. And you don't technically have to set up lens intrinsics, and there's plenty of other things you can also set up by just doing all of these things basically. I recommend setting your lens intrinsics, and there's plenty of tutorials out there, many from the first website themselves, but these I just currently have set as constants somewhere else, which is why they're not actual numbers here, but they would be. To set up your webcam so that it can actually communicate with your driver station, you need this line of code, which is where you have your device name here, and then to actually build your vision portal, which is where your op mode is going to be communicating with the camera itself. You have this vision portal builder. You set what camera you're going to use. This is webcam 1. If you're going to use multiple cameras, there is an external sample for that up here, which these are a great resource in general for all sorts of things, but I'm not doing that right now. And then we also have where you add your processor. If you are doing just one processor, great, you've done it. If you're doing multiple, you would just do this, and then for example, I can type in April type processor. And then if I want to get my data from the April type processor, I would just later in the general teleop do April type processor dot get whatever data I want from that processor in specific. So you refer to your processors themselves in your teleop itself. And then I also am setting a camera resolution to the thing I set up here. You can change this to whatever you want. And this wait for start is just because on Wolfpack we have a separate op mode method that we use just so that we can automatically update telemetry, but you don't need to have this in most of your code. And then this right here, this dashboard thing, this I will be going over later, and if you cut this out of the code, it'll work without it fine. This is just so you can actually see directly what the camera is streaming. So this is an example processor class, as per the name, and I'm implementing this thing called Vision Processor. You guys should have this, and Camera Stream Source. This is part of a dashboard, and it's not necessarily needed, and I'll explain what dashboard does in a little while, but it's another thing you implement. And now onto the variables / objects and things you're setting up here. So for starters, you're setting up this rectangle called largest rect, and this is your largest bounding box. So you're going to probably be detecting a lot of objects that have bounding boxes around them, but this will detect for the largest one because that's most likely what you're actually trying to get. And then if you're detecting multiple colors of object, I think this year we have purple and green artifacts both. You can also detect your largest purple bounding box and largest green bounding box. Now these things here, the erode constant and dilate constant. So your code is going to detect a ton of pixels, and many of which will fall under the range of color you're trying to detect that are just random pixels floating around on the screen. And what this will do is it will erode all of the contours you're seeing by 5 pixels, because I've set it to 5. And this will likely get rid of a lot of the stray pixels, and then it'll dilate it back out, but since the stray pixels are all completely gone, they don't get larger again. And so these should probably be the same, and they can get bigger or smaller, just test based on what works. This right here is just if your target's been detected or not. It's useful to have. This is your matrix, so it's like list of, well, it's a list of matrices that are your contours. The contours are the individual pixels you're detecting within your color range. And this is the list of bounding boxes you have for purple and green. Once again, you only have one if you're trying to detect only one color, but since for this game we're detecting 2, figured I'd just show the example with 2. And these are the image height and width. Right now they're 0, but you'll actually collect what they are later. And this is just data you're collecting. You can set them at 0 at the start. These are your output. This is your output matrix. And these masking layers are how you're going to detect multiple colors. If you're only detecting one color, you don't need these masking layers. Instead, you'll just have a modified, or a matrix that we often call modified, or you can just have one mask matrix, but it'll still be set up the same way. And this hierarchy thing is here. These things are for setting up dashboard. Once again, I'll explain that later. You can feel free to ignore them. If you're not using dashboard, you can get rid of them. This right here is once again for dashboard, this little config thing. However, if you're not using dashboard, all of this stuff can just go with the rest of these things. And what this is actually doing is it's setting your range of values that you're detecting. So this is an HSV color space, so the hue, this is the maximum hue, is 95 for this. Saturation value, this is the minimums for green, and this is for purple. And these are just the values that we found for green and purple for this year's game, but you will change these depending on the game. This is from a range of 255 to 0. So now we're going to be looking at the actual process frame method. So to start, we copy our input frame to the output. The output is what you as the human will be seeing. That's not actually what the camera is working with typically. The camera will be working with the green or purple mask. However, that will be all stored in binary as either white, it detects something for this pixel, or black, it doesn't, which isn't very helpful to us humans when we're trying to tune things. So this output frame is what we'll see. We're clearing up the list of contours and the list of green and purple rectangles, just so we don't have any stray detections left over. And then here we're storing the image height and width. This is really useful if you're trying to draw a line, say, across the image, or check within what half of the image something fits within. And it's useful data to save. And then this scalar right here is what actually matters. So this is taking our minimum and maximum HSV thresholds for green, and this is for purple. So this is taking the H, S, and V value from before where we saved them. And then down here is where we actually set up what color range we're working with. So for the green mask, we're selecting from the input frame, and we're telling it which color space we're going to be using. So we're going to be using so if the default is RGB, but we're going to be using HSV. If we were detecting red, for example, it's really kind of hard to detect red because while we know that the HSV color space is a circular prism, it's really hard to have that sort of thing for the code. So, and since it's just kind of a ribbon that goes from 0 to 255, red ends up being both on the 0 side and on 255. So when we're detecting things that are red, we instead do BGR and we switch where red is and green is. It's just a useful trick. But since we're not detecting red right here, we're just going to keep it as RGB to HSV. And then we're checking if things are in this range for mask green and this range for mask purple. And then right here, we've often found that the top of the matrix, or like the frame that's detecting, can be a bit glitchy and just have random detections. So we like to check within a slightly smaller frame. If you don't need this and your code seems to run fine without it and you don't get stray detections, great. But we have found that this is necessary for our code, and we're just making sure the purple and green mask only detect within this matrix. And this erode and dilate thing is what we set up the constants for earlier. This will erode stray pixels and then dilate your main image back out. It does it for the green and purple mask both. And then this is detecting your contours for both of these and saving them to this contours green list. And then this is where you are actually detecting your bounding box. This get objects detected method, which is right down here, can also be in your main process frame thing. However, I've just found it very helpful to have it down separately if you're going to be using it multiple times for multiple different things. And int color doesn't need to be an int, can be a boolean, can not be a thing. I just find it useful here because you can check actually which list you're saving it to. You don't necessarily need to save it to one of these lists. You can just kind of return your largest rectangle of whatever color you're looking for, since you actually tell you which contours, like from which contours to sort from. However, I like being able to look at the list and say, what's my second largest rectangle maybe? And the find largest contour method here, I'm just going to scroll through this, is this thing right here. So feel free to pause and copy this down if you would like. This is sorting by the largest area. And then this is just ordering your bounding recs, or saving your bounding recs in the correct order. And then back up to your process frame method. This stuff is all for dashboard, so you can kind of ignore it if you're not using dashboard. And if you are, which you probably will be, this is useful. And then you're also just going to be returning your output frame. So now the camera and the robot know what they're seeing, and they've stored the data, but what if you, the human, want to see it? And that's why we have the onDrawFrame method. And so in order to use this, what this will do is when we look at what the camera stream actually is on, say, our driver station, this will actually draw marks over it. And so in order to actually access that, you need your paint object right here, where you can set the color, the width, the style of how it's drawing. And I've set this 2 of these, so I have a green one and a purple one. And I'm checking if the target is detected, which is pretty useful to have. Just making sure we're not trying to draw something that doesn't exist. And then if we also have a largest green rectangle, then I will draw this rectangle. And if we have a large purple rectangle, I'll draw that rectangle. And this make graphics rect method is right down here. It's just something I stole off the internet. And it allows you to draw a rectangle. Yay. By now, you've heard me mention quite a bit about this thing called dashboard, or FTC dashboard. So what is it? Well, it's this really neat thing that allows you to actually live adjust your variables and live adjust like tuning values and see actually live what your camera is seeing. So I'm going to show you what that actually looks like in a second, but first I'm going to show you how to set it up. So what you're going to do is you're going to go to your build.dependencies.gradle, which I have right here, and you're going to add this implementation, and you're going to need to resync Gradle after you do that. And then from here, you're going to add in these little lines of code that I was showing you before that you could ignore. You now add in this, and then in your vision processor, at the very start of where you're setting your variables, you set up this little line of code, and you're going to be setting up this down here. And then here with this getFrame.bitmap, or getFrameBitmap, this comes in by default, but you're going to add this stuff, and for the init frame, you're going to add this stuff. Basically, you just want it to match what you can see on my screen. And then this little thing with the config right here, this is the thing that dashboard actually adds. All this stuff, so long as it's public and static both, you can actually adjust this on dashboard. So this is really helpful because let's say you're not really sure where green is. You set this to 255 and you just slowly bring it down, say by half. And if it's not within that half, and I mean, you just also start this at 0. If it's not between, say, 100 and 0, you'd say, okay, green's not within that range. Luckily it is, and that's what I did. And I said, okay, it's in this range. Is it between 50 and 0? No, it's not. So it's within 50 and 100, and you kind of narrow it down from there. And you do the same with the saturation value, although that's a bit easier. You can kind of guess that. Let's say the green you see is very saturated. You'd know if it's really quite pale. You'd also know that it's a lower saturation, and you change the minimum, and you lower the maximum a bit. And the same goes for value. Value is just how light or dark it is. So here we're looking for a fairly pale green, but some of the green is really in shadow, so it can be a bit dark. You're primarily tuning with your hue value. The saturation value are mostly just to make sure you're not seeing a bunch of random other detections that are technically green. So what does adjusting this on dashboard actually look like? Well, this is dashboard. It's just a normal Chrome web page where I've typed in the IP address of a control hub with a /dash. I think this should be the same for pretty much everyone. And I can see my op mode right here. So I can initialize and start it from here. And we can see the camera shows up. And we can see that this has been mostly tuned already. However, the purple ball isn't fully detected, and there's a few issues here. So we can actually go over here and see, alright, this max hue seems good. It doesn't seem to be having any issues detecting the hue. And it mostly seems to be having issues detecting this top part, which is probably a saturation thing. And so I'm going to turn down the minimum saturation. And we can see that this detects it much better. But it's also having trouble detecting this darkest dark right here. And this seems like more of a value issue. So instead, now we'll turn down the minimum value for purple. And this seems to be much better detection. And you can kind of mess around with all these variables like this. The only exception being hue, where you kind of just have to start with maybe a range of 0 to 100 to see if it's within that range. If it's not, then try something else. But you can eventually kind of narrow it down through that. And since you're able to live update this is a lot faster than changing your variable and re-uploading your code over and over again. With the only note being, once you're done checking everything over in dashboard, you do have to change the variable in the code because it doesn't automatically update your code. This has been a basic guide to Vision for FTC. You can contact us through our website if you have any questions or would like to meet with us. We have many other videos on your channel that can help you set your team up for success. Thank you for watching.